how does one go about creating a really interesting roof by extrusion, and perhaps using the truss tools to create some designs very quickly which would otherwise be difficult? Let's have a look in full Revit. What can be seen here is a two-story building, and there is the roof level. We can switch on an underlay which will allow us to go and create geometry close to where we want. So typically what would happen is one would extrude the roof from left to right or from bottom to top. But let's suppose you wanted to create an interesting roof across the diagonal. Then what we would have to have is a reference plane or a grid line, some other reference to which we can draw a normal plane. Using a grid line and selecting the endpoint and that endpoint, the diagonal endpoints of the building, and one may drag that a little bit wider. So the roof is going to be extruded normal to this grid line. Typically what one would need is a view that is normal to that plane, and you'd have to use this if you're using Revit LT. Using full Revit, we're going to use a different tool, but notice how you can either create that right on top of the grid line, in which case you know that it's going to be parallel, looking normal onto that plane, or otherwise I'm doing that. You will see how the section tends to highlight the grid line when it is parallel to it. Turns blue. Then you also know that that is normal. After that, one would still have to set the working plane to the grid line 1 when one is extruding the roof. A much faster way of doing this, I'm going to delete that section now. Much faster way of doing this, a more efficient way of doing this, is by using something called an elevation, a framing elevation. So framing elevations are used by structural engineers quite often. All they might want to do is to create a brace or something like that, but you will see how you can come in normal onto that grid line, and automatically what it does, let's open it up. Automatically what it does is you'll see that the grid line that it has, or the work plane that it has selected, let's see, where's my grid lines, my work planes and architecture. There we go, set the working plane. It's already set to grid 1. So automatically it sets the reference that you chose to create the structural elevation, the framing elevation from, is automatically set as the work plane. So that actually cuts out one of the little steps. What to watch out for though is notice how small the section box is. It's sectioning straight directly from that grid line, and then it is carrying onwards from there onwards. So you're only going to see half of what you're sectioning through, and then only a very short distance. But it will allow you to create that extrusion very easily. In addition to that, I'm going to need 2 more grid lines just to give me guidance as to where I'm going to create my trusses. I could create the trusses just fitting into the walls over here, so I could use the walls. So let's do that. First of all, let's go and create a wall by extrusion. Open up the framing elevation, architectural wall, roof by extrusion. We are looking at referencing that to the roof level with a 0 offset. It's fine. And then we need to sketch some of the profile going to make it nice and large. Somewhere the profile to which that roof is going to be extruded, and make that a thinner roof, and then I can accept this. The roof has been created looking at a 3D view. There we can see how it's coming in at an angle to that building. I'm allowed to drag this wider. And then what we want to do is we want to cut. And going back to the roof level, why does it look like truncated like that? And of course we know that that will be the view range, that we can just set our eye level up 5 meters and the cut level at the same height. Fly, there we go. Now we need to cut this roof, so we use a vertical cut. And notice how you have to select 2 profiles. Let's say that this roof is offset by, argument's sake, 300. Hovering on the wall there, that's 1, 2, 3, and 4. So what sort of shape will that result in? What sort of shape will that result in? Let's see. Accept. Ah, it's a negative. It's a negative shape. So, how do we fix that? There, you can clearly see it's a negative shape. How do we fix that? Well, what we can do is go into the roof level once again, select this roof, and do the vertical opening, and then we select with the 0 offset the edges of the roof. So we're creating an island, and that island will now be a positive shape. And that is what we are looking for. That's perfect. And now to create the truss. Because I'm working in the grid 1 reference plane when I'm within my framing elevation, this is quite an easy thing to do. On the structural tab, and again the guys in Revit LT won't be able to do this, and there's our truss. We can load truss family. I'm going to go with one of the simpler ones, the M flat high truss. M high flat truss, there we go. Okay, and I'm going to select this point over there. As you can see, it doesn't like to select the edge. That endpoint, no. Alright, so just escaping that, it's a good idea perhaps, go and create for yourself, create similar pick line, the 0 offset, draw a line right on top of the other grid line, and rotate about a place by 90. So this means that we will see this grid line when we're in our framing elevation. I'm going to copy this, right up to there. Let's have a look in my framing elevation. There they are. That's actually on the roof. We want this on the corner of the building. There we go. There we go. Move onto the corner of the walls. And let's have a look once again at the elevation. There we go. All right, getting back to my truss. Point number 1, it now snaps to the intersection of those references, dragging that across. It is a little bit heavy on the memory. There we go, there's the intersection. It generates that truss. The moment that truss is going to be generated as if it is a railway bridge, basically, because of the switching out into details, fine detail view. There you can see it's using some really interesting sections, universal I-beam sections, to go and create that truss at the moment. So you would have to load in some profiles to change that. That's pretty straightforward. We go insert and load families, and within the structural framing, steel, there you can see how for South Africa at least I've loaded in the British standard because our shape codes correspond. There's some circular hollow sections. You may select, let's say there's L and equal angles, L angles, so control and shift to select multiple items. We can open those and then we get our type catalog from which we can choose. Now the nice way of doing this is you can now choose different shapes and sizes from both families. There's L and equal angles. I'm going to choose something like 150 by 75. I'm going to press Control and choose another size as well. You can use Shift and Control, switch out into a different family, and then do exactly the same thing over here. It's a bit large for my liking. There we go. 100.1 and so on. Okay. That then loads those into my project, and looking at this truss, I'm allowed to edit the type, and I'm allowed to now set what sort of sections are being used for the top chords. Here where it says set framing type, I'm allowed to choose, for instance, let's go with the L angle, and there you can see automatically now switched out that with the required section, and that is what one can do. One can now just choose the correct one that one wants to use. Let's see, there's a 33, that's very tiny. So maybe I just need to load one more. Insert load family. I want about 100mm diameter. Again, from within my structural framing, steel, British standard, circular hollow sections, open. They list these by centimeters, so I'm looking at something like a 10 centimeter. That's going to give me 100 moles. 10. Let's make it a 13, 14. There we go. Okay. Edit the type, and there it is. So, and we can do this for the other sections as well. Now, how do we make a nice quick design drawing from this? What if somebody actually had to manufacture this? All right, again, we just change out the rest of them. There's the vertical webs, set the framing type. Diagonal webs. Let's have a look. Bottom chord. And so one can change them. Very nice property of this. Select the truss and then use attach top or bottom to attach it to the roof. It must be underneath the roof, but have a look at this. It actually assumes the shape of the roof. How easy is that? That is unbelievable. I can think of so many ways in which this can be used very creatively to create interesting shapes very easily. Trusses of different lengths, and angles and shapes and sizes, and it's just that easy. Why not? If the design software allows you to, why don't you? I think this is a great tool, and hopefully you think so too, and that you can use this when you are designing to create some interesting and efficient trusses for your roofs. When you want to modify one of these, you can tab to that element, unpin it, in which case you'll be able to drag that element a little bit wider. Once again, tab to that element, and there we go. Will look a bit better. What if there's some HVAC coming through here? Well, again, tab to the element, unpin it, and we're allowed to change, switching out into a wireframe view and switching on the structural model, and tabbing to that item, we're allowed to change the orientation of that member. Suppose there was a bit of HVAC coming through here, and if we really didn't want this at all, we may even tab and delete that entirely. At any time, we can reset the truss, and it will bring it back. So we can modify individual elements. If we tab into them, we can even unpin and then change what sort of section is being used. There it has now been changed to an L angle, and we can also attach framing onto this truss. Well, I hope you've enjoyed that, and I hope that this is going to inspire you to create some interesting roofs. The guttering is a different matter, of course. As long as the drainage is handled well, you should be able to create some really interesting roofs. And remember, just like with the truss, the walls may be attached to the roof as well. That's Revit for you. Nice and easy.